Welcome to the deep dive. Today, we're going to be looking at quantum computers.
Oh,
So,
okay.
you hear all this buzz about how they're going to revolutionize everything,
Right.
but what does that actually mean?
Yeah.
We're diving into excerpts from physicist Michio Kaku's Quantum Supremacy to find out.
Cool.
So hopefully we can go beyond the hype and uncover how these things could really change the world,
Yeah, definitely.
touching everything from medicine and energy to the future of humanity itself.
It's exciting stuff.
Yeah, it is. And the thing that blows my mind is that they're not just faster computers, right?
Yeah. No, they're not.
They're a fundamentally different way of processing information, opening up possibilities unimaginable with our, regular computers.
It's easy to get lost in the hype.
hmm
What's truly mind-boggling is that quantum computers aren't just faster. They operate on completely different principles than the computers we use every day.
Okay, so less like grading from a bicycle to a race car and more like
Mm.
switching from a bicycle to, I don't know, a teleportation device.
Yeah. Yeah, pretty good analogy. For decades, we've relied on Moore's law, which states that computing power doubles roughly every 2 years.
Right.
But we're pushing the physical limits of that with our current silicon-based technology.
Yeah, how small can you really make a transistor?
Exactly. Quantum computing is a potential successor, the next chapter in computing, and that's a huge deal.
So what makes them so different? I vaguely remember something about quantum computers using qubits instead of bits.
Right.
But how does that actually work?
Imagine you're flipping a coin.
Okay.
A regular computer bit is like that coin either heads 1 or tails 0.
Got it.
A qubit, though, can be both heads and tails at the same time, like the coin is spinning in the air before landing.
Okay.
That's called superposition.
Whoa, okay, my brain's already bending a little.
Yeah, it takes some getting used to.
So instead of just being a 1 or a 0, it's this blurry in-between state.
Exactly. And when you combine multiple qubits, they can become entangled, meaning their fates are linked, even if they're physically separated.
Okay, hold on.
It's like flipping 2 coins and knowing that no matter how far apart they are,
Yep.
if one lands on heads, the other will too.
Okay, that's just weird.
Yeah, quantum mechanics is definitely strange.
But how does all this weirdness translate into actually solving problems?
Right.
Kaku mentions they could have a quantum advantage over regular computers.
Yeah.
But what does that even mean in practice?
Think about a problem like simulating a complex chemical reaction.
Okay.
Regular computers would have to crunch through each possible interaction one by one,
Right.
which could take an eternity.
Yeah, that makes sense.
A quantum computer, on the other hand, could explore all those possibilities at the same time thanks to superposition and entanglement.
So it's like instead of checking each path through a maze individually,
Exactly.
it's considering all paths simultaneously.
That's the classic analogy. And this is where we start to see the quantum advantage. Problems that would be impossible for even the most powerful supercomputers,
Oh.
even given infinite time,
Yeah.
could become solvable with quantum computers.
Okay, I'm starting to see the potential here.
Yeah, it's huge.
Kaku talks a lot about how this could revolutionize medicine.
It's one of the most promising areas.
Are we talking about designer drugs and cures for diseases like Alzheimer's?
Exactly. Drug discovery is a long and expensive process.
Yeah, for sure.
Imagine using a quantum computer to simulate how a new drug interacts with the human body at the atomic level before even synthesizing it in a lab.
Okay, so you're saying we can test out new medicines virtually.
Exactly. This could potentially accelerate drug development and lead to breakthroughs in treating diseases like Alzheimer's, which, as you know, has baffled researchers for decades.
So no more massive testing facilities, just virtual laboratories in cyberspace. That's pretty incredible.
It's a game changer for sure.
And what about Alzheimer's specifically? Can quantum computers really help us understand and treat this disease?
Well, Kaku highlights the potential for understanding how misfolded proteins, called prions, contribute to diseases like Alzheimer's.
Okay, I've heard of prions.
If we could simulate how these proteins fold, we might be able to design drugs that prevent them from misfolding in the first place, or even reverse the damage.
Wow, that could be huge.
Absolutely. It's
Like-
one of the most promising areas of research in quantum computing.
He also talks about how quantum computers could tackle the energy crisis, right?
Right. One of the biggest roadblocks to widespread adoption of renewable energy is efficient energy storage.
That's true.
The sun isn't always shining, the wind isn't always blowing, so we need better batteries to make solar and wind power more reliable.
I see. And he specifically focuses on fertilizer production.
Yeah.
which is incredibly energy intensive. It uses up a huge chunk of the world's energy, right?
Exactly. The current method of making fertilizer, the Haber-Bosch process, requires massive amounts of energy to convert nitrogen from the air into ammonia.
Right.
It's like using a sledgehammer to crack a nut.
But bacteria do it for free. He mentions nitrogen-fixing bacteria that can convert nitrogen from the air into a usable form for plants without all that energy expenditure.
And that's where quantum computers could help. They could help us understand how those bacteria do it, potentially leading to a more efficient, energy-saving way to produce fertilizer, and maybe even entirely new types of batteries.
So it's not just about simulating existing processes.
Nope.
Quantum computers could help us unlock entirely new solutions.
It's like having a digital alchemist.
But before we get too carried away, Kaku also touches on the weirdness of quantum mechanics itself.
Yeah.
He mentions Schrodinger's cat.
Ah, yes, the cat that's both dead and alive.
I never understood that one.
It's a thought experiment that illustrates the concept of superposition, that idea we talked about earlier where a qubit can be in multiple states at the same time.
So before you open the box and look, a cat isn't in some weird limbo state.
Right.
It's that our observation forces it to choose one state or the other.
Exactly. It highlights how our everyday understanding of reality breaks down in the quantum realm.
Okay, so quantum mechanics is strange. But Kaku doesn't stop there. He connects quantum computing to artificial intelligence. Is this the key to finally creating those super intelligent machines we see in sci-fi movies?
Well, AI has had its ups and downs. There are two main approaches. Top-down, where you program explicit rules,
Okay.
and bottom-up, where machines learn from experience. Both have limitations.
Right, like how even the most advanced AI struggles with things we find easy, like understanding sarcasm or common sense.
Kaku suggests that quantum computers could boost both approaches. For top-down AI, they could help us simulate the brain in more detail.
Interesting.
For bottom-up AI, they could analyze massive amounts of data to find patterns we might miss.
It's not that they'll magically make machines intelligent.
No.
It's more like they could give us the tools to understand and maybe even replicate intelligence.
Okay.
I'm seeing how quantum computing can be a major game changer. But where does all this incredible potential come from? Kaku takes us all the way back to the origins of life, right?
Yes. He emphasizes how quantum mechanics was crucial to understanding the structure of DNA. It's amazing to think that this strange, counterintuitive theory is at the heart of biology itself.
It's a quantum mechanics isn't just a physics thing.
No.
It's woven into the very fabric of life. He also talks about the Human Genome Project, this huge effort to map all human genes.
Right. And this project wouldn't have been possible without the tools and insights provided by quantum mechanics. It's paved the way for personalized medicine where treatments can be tailored to your individual genetic makeup.
And Kaku envisions quantum computers taking personalized medicine even further. Imagine analyzing an individual's entire genome to identify disease risks and develop targeted therapies.
A revolutionary idea.
And he leaves us with the most mind-blowing possibility of all. He suggests quantum computers could help us tackle the deepest questions about the universe itself.
It's the ultimate frontier.
Okay, now this is where it gets really interesting. We're talking about simulating the Big Bang, figuring out what dark matter and dark energy are, even exploring the possibility of parallel universes.
Right.
It's like using these machines to peek behind the curtain of reality.
Exactly. And that's what makes this deep dive so compelling. It's not just about the science. It's about what it means to be human in a universe that's far stranger and more wondrous than we ever imagined.
This is incredible. We've barely scratched the surface of quantum supremacy, and my mind is already blown. We'll be right back after a short break to delve deeper into the specific ways quantum computers could change the world. Welcome back to the deep dive. Before the break, we were talking about how quantum computers could help us understand the universe better.
It's pretty amazing stuff.
Simulate the Big Bang, maybe even shed light on dark matter and dark energy. It's mind-boggling.
It is, but even beyond those big cosmological questions,
Right.
quantum computers have the potential to revolutionize fields much closer to home. For instance, let's get back to that energy crisis we were talking about. Kaku really dives into how quantum computers could help us create far more powerful batteries than we have today.
Okay, this is something everyone can relate to. We all want better batteries for our phones, laptops, and especially for electric cars, and storing renewable energy.
Absolutely.
But haven't we hit a wall with current battery technology?
You're right. Improving batteries has been a real challenge.
Yeah.
We've made progress, but not at the same incredible pace as computing power.
Right.
Take the lithium-ion battery, the workhorse of most modern devices. We're pushing its theoretical limits.
So where do we go from here?
To get to the next level of energy storage, we need entirely new chemistries, entirely new materials.
And that's where quantum computers come in, right?
Mm,
Could they really help us design those new superpowered batteries?
absolutely. Imagine you're trying to create a new battery.
Okay.
You need to understand how atoms and molecules will interact at a very fine-grained level. That's a problem perfect for a quantum computer, which can handle the complexity of those interactions with far greater speed and accuracy than any classical computer.
So instead of spending years in a lab mixing and testing different materials,
Yeah.
we could use a quantum computer to simulate those experiments, virtually identifying the most promising candidates much faster.
Precisely. Kaku specifically mentions the lithium-air battery as an example.
Okay.
It has the potential to store way more energy than lithium-ion,
Wow.
but suffers from a short lifespan.
I see.
Quantum computers could help us figure out what causes that degradation at the atomic level,
Okay.
allowing us to design much more durable batteries.
That's pretty amazing. He also mentioned something called supercapacitors, which I'm not as familiar with.
Oh, yeah.
Are those another potential area for quantum computers to make a difference?
Definitely. Supercapacitors can charge and discharge much faster than batteries.
Interesting.
They store energy by accumulating ions on a surface. Quantum computers could help us understand and optimize those surface interactions, leading to even more efficient and powerful supercapacitors.
We're talking about a real revolution in how we store and use energy. Quantum computers could impact not just individual industries, but the very foundation of our energy infrastructure.
It's really a paradigm shift,
Yeah.
and it's not just about energy storage.
Okay, what else?
Kaku also points out that quantum computers could revolutionize the way we produce energy. Remember those nitrogen-fixing bacteria we talked about earlier?
Yeah, the ones that can make fertilizer using just air and sunlight.
Right.
Seems like magic compared to our energy-guzzling industrial processes.
Right. Imagine if we could use quantum computers to figure out the secrets of those bacteria.
Yeah.
To unlock a cleaner, more efficient way to produce fertilizer. That could have a huge impact on global energy consumption and food production.
So it's like we're learning from nature to create better technologies.
Exactly. Nature has had billions of years to perfect these processes,
Right.
and quantum computers could help us unlock those secrets.
Okay, so we've got medicine, we've got energy. What about artificial intelligence? We touched on that briefly before the break.
Yeah.
But Kaku devotes a whole chapter to how quantum computers could supercharge AI.
It's one of the most exciting and potentially transformative applications of quantum computing.
Okay, I'm intrigued.
It's not just about faster processing.
Yeah.
Quantum computers could give us the tools to understand intelligence itself,
Wow.
to model the complexity of the human brain, and perhaps even create machines that can truly think for themselves.
That's a bit of a scary thought, isn't it? What happens when machines become as smart or even smarter than humans? It's like something straight out of a science fiction movie.
It's a valid concern, and one that Kaku doesn't shy away from.
Good.
He argues that we need to be proactive in addressing the ethical considerations of advanced AI.
Yeah, for sure.
But he's also optimistic that quantum computing could help us develop AI in a way that benefits humanity.
I like that perspective. It's not about fearing the future, but about shaping it responsibly.
Exactly.
Yeah.
We have a choice in how we develop and use this technology.
Okay, so we've covered a lot of potential benefits of quantum computing. But I have to ask, are we just talking about pie-in-the-sky dreams here?
That's a fair question.
Or are there any concrete examples of how quantum computers are already making a difference in the world?
That's a great question, and the answer is both. While quantum computers are still in their early stages of development, they're already being used in research and development. Some companies are even offering cloud-based access to quantum computing resources.
So it's not like we have to wait decades to see results.
Yeah,
Quantum computing is happening now, and it's only going to become more powerful and accessible in the years to come.
that's exactly right. And Kaku highlights several areas where we're already seeing real-world impact.
Like what?
One area that really stands out is material science.
Material science, you mean like designing new fabrics or building stronger bridges?
Those are certainly applications of material science, but think even bigger.
Okay.
Quantum computers are being used to design entirely new materials with properties we've never seen before.
I'm listening.
Remember how we talked about the limitations of current battery technology?
Yeah.
Quantum computers are being used to design new materials for more efficient and powerful batteries,
Why?
as well as for a wide range of other applications, from solar cells to catalysts for chemical reactions.
Okay, that makes sense. But how exactly are quantum computers being used to design new materials? It sounds a bit like magic.
It's not magic, but it is mind-boggling. Remember how we talked about quantum computers being able to explore multiple possibilities simultaneously?
Yeah, that was the maze analogy.
Exactly. That's essential for materials design. Instead of randomly mixing and testing different elements in a lab, which could take years,
Right.
we can use a quantum computer to simulate those interactions with incredible speed and accuracy.
Okay.
It's like having a virtual laboratory that can test millions of combinations in an instant.
So we're talking about dramatically accelerating the pace of discovery, potentially leading to breakthroughs in fields like energy medicine and manufacturing.
Exactly. And it's not just about designing entirely new materials. Quantum computers can also be used to optimize existing materials to fine-tune their properties for specific applications.
Okay, I'm starting to grasp the potential here. But are there any specific examples of companies or research groups that are already using quantum computers to design new materials?
Absolutely. There are numerous companies and research institutions that are actively exploring the potential of quantum computing for materials science.
Okay, give me an example.
For example, Google AI has been using quantum computers to simulate the properties of materials for solar cells and catalysts.
That's impressive. And are there any companies that are already offering commercial quantum computing services for material science?
Yes, there are several companies that offer cloud-based access to quantum computers.
So you're saying anyone can use them?
Not just anyone, but researchers and businesses can use them
Okay.
to run their own simulations and experiments. For example, IBM offers access to its quantum computers through its IBM Quantum Experience platform.
So it's not just a research project anymore. Quantum computing is becoming a practical tool for scientists and engineers working to develop the materials of the future.
That's exactly right. And as quantum computers continue to improve in power and accessibility, we can expect to see even more exciting breakthroughs in material science and other fields.
This is incredible. We've covered a lot of ground here: medicine, energy, AI, material science. It seems like quantum computing has the potential to touch every aspect of our lives. But what about the human side of things? Does Kaku address the ethical implications of this technology?
He does. In fact, he devotes a significant portion of the book to exploring the philosophical and ethical considerations of quantum computing.
Good.
He argues that as we develop this powerful technology, we need to be mindful of its potential impact on society, on humanity, and on our very understanding of the universe.
Okay, that's reassuring. It's easy to get caught up in the excitement of the science, but it's important to remember that technology is a tool, and like any tool, it can be used for good or for bad.
Absolutely, and that's why Kaku emphasizes the importance of having a conversation about the ethics of quantum computing, a conversation that involves not just scientists and engineers, but also philosophers, policymakers, and the public at large.
I like that. It's not just about the technology itself, it's about how we use it and what kind of future we want to create with it.
Exactly. And Kaku believes that quantum computing has the potential to be a force for good, to help us solve some of the most pressing challenges facing humanity. But he also acknowledges the potential risks and urges us to proceed with both caution and a sense of responsibility.
Well, I have to say this deep dive has been an incredible journey so far. I'm feeling both excited and a little overwhelmed by the sheer potential of quantum computing.
I understand. It's a lot to take in, but I think the most important thing is to remember that we're just at the beginning of this journey. The future of quantum computing is still being written,
Right.
and we all have a role to play in shaping it.
That's a powerful thought. We'll be back after a short break to continue our deep dive into the world of quantum computing. Stay tuned. Welcome back to the deep dive. We've been exploring Michio Kaku's Quantum Supremacy and unpacking the incredible potential of quantum computers. It's been quite a journey.
It really has. We've talked about how quantum computers could transform everything from medicine and energy to material science and AI. But Kaku doesn't stop there. He pushes us to consider the even bigger picture, the fundamental questions about the nature of reality itself.
This is the part that always gets me, the part where science starts to sound like philosophy. He talks about using quantum computers to simulate the Big Bang, right? How can we possibly recreate the conditions of the early universe in a computer?
It's definitely a challenge, but not as far-fetched as it might seem. Think about it this way. Simulating the Big Bang involves understanding the behavior of matter and energy at incredibly high temperatures and densities, conditions that are impossible to create in a lab.
Okay, so we need a way to study those extreme conditions without actually creating them. Is that where quantum computers come in?
Exactly. Quantum computers, with their ability to handle superposition and entanglement, could potentially simulate those extreme conditions with a level of accuracy and speed that's just not possible with classical computers.
So we're talking about potentially recreating the Big Bang in a virtual universe inside a quantum computer. That's mind-boggling. What could we learn from such a simulation?
The possibilities are endless. We could gain insights into the fundamental forces and particles that shape the universe as we know it. We could potentially answer questions about the nature of dark matter and dark energy, which remain some of the biggest mysteries in cosmology.
Okay, I'm trying to wrap my head around this. We could potentially rewind the universe and see what happened in the first moments after the Big Bang.
It's a tantalizing possibility, and it highlights the potential of quantum computers to not just solve practical problems, but to expand our understanding of the universe in ways we can barely imagine.
This is incredible. But I have to ask, what are the practical implications of all this? Will understanding the Big Bang help us solve problems here on Earth?
That's a great question. And while it's impossible to predict the future with certainty, history has shown that fundamental scientific discoveries often lead to unexpected technological breakthroughs.
So even if we don't find immediate practical applications, studying the Big Bang with quantum computers could open up entirely new avenues of research and innovation.
Exactly. It's like exploring a new continent. We don't know what we'll find, but the potential for discovery is immense. And who knows, maybe understanding the origins of the universe will give us insights into how to create a more sustainable future here on Earth.
That's a hopeful thought.
Mhm.
Okay, so we've talked about the science, the potential benefits, and the big philosophical questions. But throughout this deep dive, I keep coming back to one question. What are the risks? What happens if this incredible power falls into the wrong hands?
That's a crucial question, and one that Kaku addresses head on. He acknowledges that quantum computing, like any powerful technology, has the potential for misuse.
He mentions code breaking specifically, right? How quantum computers could potentially crack the encryption that protects our online transactions and communications.
Right. Many of our current encryption methods rely on mathematical problems that are very difficult for classical computers to solve, but that quantum computers could potentially crack with ease.
So our digital security could be at risk. What can we do about that?
The good news is that researchers are already working on developing new encryption methods that are resistant to quantum attacks. These methods, known as post-quantum cryptography, are designed to withstand the power of quantum computers.
So it's an arms race of sorts. Cryptographers are working to stay one step ahead of those who might use quantum computers for malicious purposes.
Exactly. And it highlights the importance of investing in cybersecurity research and developing international agreements to ensure that quantum computing is used responsibly.
Okay, that makes me feel a little better.
Hmm.
But I'm still struck by the sheer power of this technology. It feels like we're on the cusp of something truly transformative, something that could change the course of human history.
That's a great way to put it. And I think that's the most important takeaway from quantum supremacy. Kaku wants us to approach quantum computing with a sense of both wonder and responsibility. He urges us to embrace the possibilities, but also to think carefully about the implications, both positive and negative.
It's like we're holding a key that can unlock incredible potential, but we need to choose the right door to open.
That's a perfect analogy. And Kaku leaves us with a challenge, a call to action. He encourages us to engage in the conversation about quantum computing, to learn about this technology, and to help shape its future in a way that benefits all of humanity.
Okay, I'm ready to accept that challenge. This deep dive has been eye-opening, inspiring, and a little bit terrifying all at the same time. I can't wait to see what the future holds for quantum computing and what role we'll all play in shaping that future.
Me too. And remember, even though the science can get complex, the core message is simple. The future is not predetermined. It's up to us to create the world we want to live in.
That's a powerful message to end on. Thank you for joining us on this incredible journey into the world of quantum computing. To our listeners, we encourage you to continue exploring, learning, and asking the big questions. Until next time, keep diving deep.